Hello everyone. Today I'll be explaining my questions 4 and 5.
A. I need to find the x-intercepts of the graph. The x-intercepts are the points where the graph crosses the x-axis. For the first x-intercept, this formula uses the positive version of the quadratic formula to calculate x1, which gives me a value of 1.170. Next, this formula uses the negative version of the quadratic formula, which gives me a value of negative 3.221. After calculating both values, I found out that the graph crosses the x-axis at x equals 1.170 and x equals negative 3.221. Moving on to question 4b, I converted the equation into vertex form. The value of a is 0.195. For m, the formula calculates m using b divided by 2a, as shown in the cells over here. Using the values from the equation, m gave me a value of 1.026. Then for n, the formula substitute the vertex x value into the original equation to calculate the y value. Thus, I get negative 0.940. Therefore, the equation in vertex form is y equals 0.195 open bracket x plus 1.026 close bracket square minus 0.940. From this equation, the vertex is open bracket negative 1.026 comma negative 0.940, which is the turning point of the graph. For question 5a, I used trial and error to fit the quadratic graph to the bridge curve. I adjusted the values of a, b, and c and observe how the graph has changed. So changing a affects the shape of the parabola. So instead of making it 0.1, I make it 0.195. Changing b moves the graph left and right. So instead of 0.1, I'll do 0.4. And for c changes the graph to go up or down. So instead of 0.7, I'll put negative 0.735. So I continue adjusting these values until the graph closely matched the bridge curve. 5b, for this cell, I'm allowed to use points on the blue curve to input x values here. So as you can see in here, I've put the value to 6, but I can also change it back to 1. A more accurate method is to use points from the target curve. By substituting 3 points into equation y equals ax squared plus bx plus c, I can calculate the values of a, b, and c mathematically instead of relying on trial and error. This produces a more accurate model of the bridge curve.
To conclude, I found the x-intercepts of the graph and converted the equation into vertex form and used the quadratic equation to model a real-world bridge curve. This assignment helped me better understand how quadratic equations can be applied to real-life situations. Thank you for watching and have a great day.